Okay guys, here we go. We are at the end of chapter 6. We have reached the pinnacle of this entire unit, the binomial theorem, often considered one of the toughest things we do all year. But really it's not that bad if you break it down and look for the pattern, because after all that's what math is all about, describing patterns with our symbolic language. So I'm going to start with this problem, because if we can do this, this is basically what the homework is. It's problem 15, and it's asking us to expand a plus 1 to the 10th, okay? And by expand, I mean this. No, I don't mean that. We just don't make it bigger. Expand in math means multiply. Multiply it all out. So what this is saying, a plus 1 to the 10th, is saying, what is a plus 1 times a plus 1 times a plus 1, so on, all the way up to our last, our 10th, a plus 1. We're going to multiply 10 of those all out and make some big expansion of that. All right? Well, you can, if you want to just give it a try, you can pause the camera and you can start multiplying and multiply all out, and then come back in a week and let me know what you get. Or we can look for the pattern, and then we can just sort of jump to the end knowing what that pattern tells us it will be. So to get that pattern discovery started, let's try the simplest little example. We'll get away from this particular example to just any old two things. Two things together is our binomial, right? Bi just means two and nomial means terms. And if we're expanding it to some power n, let's look at the simplest power that could possibly be, and we'll do a plus b to the 0. Well, anything that's not 0 raised to the 0 is 1, okay? So 7 to the 1, 7 to the 0 is 1, 10 to the 0, a million to the 0 power is 1. A plus b to the 0 is also 1, as long as you don't get 0 in there. So the next would be then a plus b to the first. Well, anything to the first power is just itself, so that's going to be a plus b. Next would be a plus b to the second, okay? Well, if you think it's a squared plus b squared, just get really close to your monitor, because I'm going to come over and pop you one. There you go, because we've done this a million times, and this is not a squared plus b squared. You've got to FOIL this out, all right? So you've got to write a plus b times a plus b, and yes, you get a squared when you multiply the first, and you get b squared when you multiply the last, but the inside and the outside in our FOIL will give you AB and BA. Well, that's the same as 2 ABs, so I've got plus 2AB plus B squared there. Okay, that's the correct expansion of A plus B squared. A plus B to the third, then, is going to be this times another a plus b, because it's a plus b times the third a plus b. So you don't have to write this down in your notes, but watch me do it. If I bring that a into all three of these, I get a to the third, and then plus 2, a times that a is a squared plus times b, then plus a b squared right there, and then I've run out of a, so I'm going to go on to the b. If I do the b to each one of these three, I then get a squared b. Well, I'm going to line that up with this a squared and b. I only have one of them, because this b times that a gives me a squared, or that a squared gives me a squared b. Here, when I multiply it, I get the 2ab squared. And again, I'm lining these up by similar creatures. This creature is an a squared b, whereas this is an ab squared, and they're different. And then finally, I get plus b to the third, okay? So that's just using our algebraic notation for exponentials, but now I need to combine like terms. There's no like term there, a to the third. 2 plus 1 of these critters gives me 3 a squared b's. One of these plus 2 of those critters gives me 3 a b squareds, and then finally I get plus b to the third. So that's my final answer for the expansion of this right there. All right? Well, like I said, we're looking for patterns, and you can maybe think about what this is to nudge you along the way. Look at the coefficients here for these numbers. All right? That's an invisible 1. That's a pretty obvious 2. Whoops, yeah, that's right. And there's an invisible 1. There's my 1 up there. here's an invisible 1a to the third. I'm going to actually jump down here to go to the final result. There's 3, and there's 1. And using the blue as a highlighter, you can see that there is a special pattern here, okay? And that is Pascal's triangle. So these coefficients, by the nature of the way we add them, it's always going to be 1 plus this number sort of above it or to the side of it or whatever, but it will produce Pascal's number. So a plus b to the fourth then is fairly easily done without multiplying this yet again by another a plus b. It's going to be my fourth row of Pascal's triangle with 1 and then 4, 6, 4, and 1. My first coefficient for my first exponent for my variable is always going to be the same as that exponent right there. Here's a 3, so there's a 3. It always starts and ends with that exponent, so it's going to be 1a to the fourth. It's going to end with 1b to the fourth. And then in between, the a's go down by 1 notch in the exponent each time, and the b's go down by 1 notch going in the other direction. So that's a to the third, that's a squared, that's a to the 0, but it just drops away to 1. This is b to the fourth, this is b to the third, this is b squared, this is b, and then that's b to the 0, and that drops out. And then just careful, put pluses in, because we're adding up these terms. And that is my expansion of a plus b to the fourth. Okay? Well, we now are able to think about this expansion if we use that pattern. All right, so I'm going to erase the board here. You run and get Pascal's triangle, as I am too. All right, well, I got Pascal's triangle and I had to get a marker, so I'm all armed and dangerous. All right, I go to the 10th row of Pascal's triangle. I write down the numbers. It goes 1, 10, 45, 120, 252, 210. That's not right. I'm missing 120, 210, 252. 210, 252, and then it goes back down to, I'll bring it down here, to 210, to 120, to 45, to 10, to 1. Now, if you ever get stuck, because it's sometimes hard, just count. There should always be 11 numbers in the 10th row. So that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So I got them all. And it should be symmetric with 1s, 10s, 45s, 120s, 210s, and the largest one is always in the middle. So that's how I spotted the mistake. All right, well, and you also want to make sure you leave enough room for the pluses and all the other numbers. I definitely have not done that, but I'll write extra teeny, and it should work. So then it goes a to the 10th here, and then a to the 9th, and then a to the 8th, and then a to the 7th. It's boring, but it's sure a lot better than, that's a to the 5th, okay? Sure a lot better than multiplying for like a week and making a mistake. So a to the 4, then a to the 3rd, then a squared, and then a to the 0. And then I just do the reverse coming back. It's not b though, it's 1. So 1 now to the 10th is just going to be 1, and 1 to the 9th is just going to be 1, and 1 to the 8th is just going to be 1. So I can just stop right here and put pluses in there, and I am done with that homework problem. There's a plus, 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 and there's a plus, all right? And that's basically your final answer. It is an expanded form. It gets more difficult when you have something along the lines of like x minus 3 to the 7th. Because then what you're going to do is you're going to plug in a negative 3. This is like saying plus a negative 3. And that's my a, there's x. That's my b, it's a negative 3. And then I would go through the 7th row. I'd write all the coefficients for 7. I'd sub in this for every a, and I'd sub in that for every b. And when it says b to like the 7th, I've got to actually take that negative 3 and raise it to the 7th. But that's what we'll be doing in class. This is just meant to get you started. So for the homework type check, to make sure you've done this, why don't you do a simpler one? Why don't you do something like this, x plus y to the 6th, okay? Why don't you try expanding that and bring that in for homework. Thanks a lot. See you tomorrow.